and good morning from the Netherlands on what is set to be a milestone in the history of manned spaceflight. In less than half an hour, we should see the launch of the FGB, the first module of the International Space Station, and the start of a new era of space exploration and international cooperation. Today's programme comes live from ESTEC, the European Space Agency's research centre. I'm actually standing in what's known as the High Bay, which is shortly to become ESA's Space Station Information Centre. In a moment, we'll bring you an update of the launch, but first I'd like to introduce my fellow host, European astronaut Thomas Reiter. Thomas.
Good morning. At the moment we are connected to about 30 sites across Europe, and I also welcome our viewers from Bavaria Alpha. Herzlich willkommen nach Bayern. I'm delighted to introduce to you the chairman of the German Space Agency, Professor Walter Gröll, and the director of manned spaceflight of the European Space Agency, Dr. Jörg Feustel. Later in the program, we will be hear from our panel of invited guests.
Well, thank you, Thomas. Well, we're only about 40 minutes away now from the launch of the first module of the International Space Station. Now, this element is Russian-built, and it's been given the name Zaria, which in English means dawn or daybreak. At the moment, Zaria is the payload sitting on the top of a proton launcher at the Baikonur Cosmodrome in Kazakhstan, and we can see it there right now. The countdown is continuing, and so far there have been no reports of hold-ups. But of course, we will be covering, as I've said, the launch live and bringing you information as we get it. Well, before we go any further, let's just get into perspective the enormity of the task to construct the International Space Station. It's a collaborative venture and draws on the technological expertise of 15 countries. On current estimates, it will take 5 years to complete, but it will be operational long before then.
A new era in space exploration is about to begin as the assembly of the International Space Station gets underway today. It will be the largest structure ever built in space, and Europe is one of the 5 international partners involved, along with America, Russia, Canada, and Japan. Today's launch of the Russian-built Zaria module, also known as the FGB, or Functional Cargo Block, is, however, only the first of many over the next 5 years. That's because the International Space Station is made up of many purpose-built modules, ranging from living quarters for astronauts to space laboratories. One of Europe's main contributions is the Columbus Laboratory, a manned scientific module. The laboratory is significant because it represents Europe's achievements in developing space hardware and an astronaut program. Its expected crews could spend up to 3 months on board. When fully built, the space station will be huge. Weighing 400 tons, the longest surfaces run 108 meters by 74 meters. This is the same sort of scale as a football field in space. It will circle the globe about 460 kilometers high every 90 minutes at an orbital inclination of 51.6 degrees to the equator. This enables the station to overfly 85% of the total surface of the Earth, where 95% of the population lives. From this vantage point, the space station will be in a position to help solve many scientific and environmental problems found on Earth, but from a space perspective. It's intended the station will benefit everyone by using a space environment to support scientific research and technical development on Earth. Eventually, research teams of up to 7 astronauts could be permanently based in space. Such a huge project will take several years. About 45 separate missions are planned to complete the construction, using space shuttles and Russian launchers. Europe is involved in 19 of these assembly flights with European-made hardware elements.
Well, it's a very exciting day. Mr. Feustel, I'd like to come to you straight away. Just how significant is this day in manned spaceflight in Europe?
This is, for us, of course, a great day because it marks an important milestone in the program. after a very long preparation period of almost 10 years, we are now going into the real phase of the International Space Station, and with the launch of this first element, we are actually opening today the assembly phase of the International Space Station, which will take another 5 years in front of us. And then from 2003, 2004 onwards, we are going to use that wonderful piece in orbit for another 10 years. So it's really marking the beginning of the hardware phase of this undertaking.
Well, it is, as I say, a very exciting day, and it's all now becoming reality. What exactly is the European share in the station?
The European share is rather small. We have about 5% of the overall station, but nevertheless it is quite remarkable. We are actually doing a number of things, among which we will have a laboratory. We call it Columbus, which will be our real estate in space. And this is one of our major developments. But we are not only participating in the infrastructure in orbit, we are also participating in the operation of the space station. And to this extent, we will use our launcher Ariane 5, which just recently has made great success. And we are developing for Ariane 5 a new intelligent upper stage, which allows us to transport up to 10 tons to the International Space Station every year. And apart from that, we have many smaller contributions. Some of them we have already delivered to our partners. So Europe will participate in almost every second of the forthcoming 50 assembly flights.
That's marvellous. Professor Kroll, I'd like to come to you now from the German space agency, DLR. Why build a space station? Why do we need one?
To build that station has been a political decision of the governments involved. They wanted to take up a challenge jointly, combining those who formerly have been competing or even fighting with each other to share costs, to share work, and to build an outpost in space. The challenge is to build an infrastructure and to use it. An infrastructure for research, technology development, and combine that infrastructure with our terrestrial infrastructure, finally to enrich our life.
It's obviously significant in terms of finance, and Europe, as you've just said, has got an enormous contribution. But where does the main finance from Europe come from?
There are three main contributors in Europe. This is Germany, France, and Italy. But overall, there are 10 European countries participating. Belgium, the Netherlands, the Nordic countries, Sweden, Norway, and Denmark, Spain, and Switzerland.
Right. Thank you very much, gentlemen, for the moment. Thomas.
It has been a long and difficult process to make the International Space Station a reality. Over the last 40 years, the Americans have proposed about 40 designs for their own station. The Russians pioneered with great success the space station Mir, which has been flying now for more than 12 years. We Europeans pioneered with flying laboratories, and all of that expertise is essential to this international venture.
The first attempt by the Americans to put a space station in orbit was made in 1973 with the launch of Skylab. This was built using the technology that took men to the moon and consisted of the top stage of a Saturn V launcher modified into an orbital workshop. The dream of building a space station, however, began back in the 1950s, but costs were always prohibitive. Only today's international partnership has realized these early ambitions. Skylab, however, proved men could do meaningful research in space. But after 2 years of operation, it was abandoned and crashed back to Earth in 1979. In competition with the Americans, the Russians had also experimented with space stations during the 1970s. Their Salyut program began to grapple with the logistics of resupply and extended crew missions, the longest being 185 days. Three major factors have made the International Space Station possible. The success of the American Space Shuttle as a carrier of astronauts and hardware, the success of the European-made Space Lab, which converted the shuttle into a temporary space station, and the technical experience gained during the operation of the Russian space station Mir. For the last 5 years, both the Western partners and Russia have cooperated and mounted joint missions, and Russia was invited in 1998 to become a space station partner. Europe had already been involved with the space station since 1988 and will provide the successful Ariane 5 launcher to ferry supplies. Through ESA, Europe also has a long history of developing space hardware. It was the development of Space Lab, a manned orbiting laboratory transported inside the shuttle's cargo bay, that opened up the manned space arena for Europe. In 1983, the world's first reusable orbiting laboratory, designed and built in Europe, was launched for the first time, providing a comfortable, shirt-sleeved environment for scientific research. In conjunction with Space Lab, Europe developed an astronaut training program recruiting astronaut candidates from many disciplines. European astronauts are now training with NASA for space station missions. Today's launch is thus the result of many years of pioneering work and dedication. For Europe and the other international space station partners, it's the start of a year's intensive activity before the first astronauts are able to live inside.
We've now been joined by Mr. Claude Guinet, who is the Space Director of Matra Marconi. Mr. Guinet, can Europe make a real contribution on the station on solid industrial grounds?
Well, European industry has quite an experience in space. We are among the leaders in the world, and we can capitalize on Space Lab, which was our first experience in manned space program. The space station is offering us a lot of challenges, obviously, because it's a new dimension with a man in the loop. And I can take an example of these challenges, the in-orbit, automatic in-orbit rendezvous between the ATV, the vehicle which will bring the freight on board the station, and the station itself. It's a very delicate and complex maneuver, and this has to be executed in a very timely fashion and in a very safe way, because we have astronauts on board and we need to bring them all goods and freight. This we will realize, and it's a challenge that will place us at the level of our competitor in the world.
Thank you, Mr. Guinet. Let me ask Mr. Feustel, has ESA's role as a technical innovator enabled Europe's participation?
We actually see our role in two directions. First of all, we want to assure continuity. We are building on solid experience on the one side with Space Lab, for instance, where we have played a major role. On the other side, we also feel ourselves as a stimulator for new technologies which are applied in the International Space Station, but also as a stimulator for new applications and new research programs. And I am just coming from a conference which we had here in ESTEC, where we had 550 users, and I tell you, it was very exciting to see their bright new ideas for using the space station. And this is one of our biggest challenges in front of us, to find a proper and adequate and fruitful utilization of the space station.
Thank you. So also in this regime, a very good perspective for the future. Professor Grell, Germany has played a major role in Space Lab and will also do so in the station. As head of the German Space Agency, how important is program continuity in your eyes?
In high technology as well as in research, there is no success without continuity and commitment. Airbus or Ariane, which have been mentioned, are good examples for that, but there are many others in other areas. So what you really need, and what we started with Space Lab and other activities, is to get people devoted, committed, with long breath to work on this issue and to open up options and opportunities and to use them.
I guess this is especially true for also the financial support for such programs.
It is. This is one important aspect to it. As has been mentioned earlier, there is a considerable amount of money, of taxpayers' money, going into that project. But on the other hand side, as was mentioned, the European contribution over the next 7 years, mounting up to 3 billion euros, is comparatively small with regard to the overall cost of the issue. And I do hope that we get our money's worth back from this international activity.
I'm sure that you will. Well, the launch is still actually scheduled for 7:40, so we've got approximately 25 minutes to wait. Let's have a look at some pictures that we've got by satellite from NASA television and see what's going on there at the moment. There we are.
By a Russian Soyuz capsule. It featured improved avionics and attitude control. And now it could be refueled on orbit, extending the time it could provide power and propulsion control for the station in case of a launch delay for future components. In January 1998, in front of a large group of dignitaries, including the shuttle crew tapped for the first station assembly mission, the control module was unveiled at the Khrunichev factory for all the world to see. The first element of the International Space Station, ready to take the next step toward launch. Later that month, it was placed on a special rail car for the 5-day, 1,200-mile journey to the Asian launch site at the Baikonur Cosmodrome in Kazakhstan for final testing and launch preparation. While engineering teams at Baikonur completed that work, the International Space Station partners met in the U.S. this summer and agreed on a November launch date for the module and on a name. This first element of the station would be known as Zaria, the Russian word for sunrise. This month, perched atop a Russian proton rocket, Zaria was rolled to the launch pad at Baikonur for the final countdown. It will be joined to the second element, a connecting port called Unity, during the space shuttle mission targeted for launch December 3rd.
Back at the launch site of the Baikonur Cosmodrome, the Proton stands ready for launch as officials conduct a second check of the Proton's onboard batteries, having just completed the realignment of the rocket's trajectory control system. Just a few minutes from now, Zaria's telemetry systems will be activated and monitoring of the Proton's thermal systems will begin. At the T-minus 10-minute mark, the Proton's steering jets will be activated as well. The countdown currently stands at T-minus 21 minutes, 14 seconds, and counting. All systems reported to be ready for the launch of the Proton rocket on the first flight of the International Space Station. Here at the Russian Mission Control Center, flight controllers are ready to begin their job of monitoring Zaria following its launch and insertion into orbit. Khrunichev, which built the Zaria, is responsible for operating it on orbit through the launch of the Russian service module next summer. U.S. flight controllers also occupy a room not far from the large control room here, comprising the so-called Houston Support Group. Their responsibility is to work in concert with the Russian flight controllers in monitoring Zaria's systems while reporting directly to NASA's International Space Station Flight Director back in Mission Control in Houston. For both Russian and American flight controllers, it will be a busy time once Zaria reaches its position in orbit.
Zaria's onboard complex control system, the computerized brain of the module, will be active during launch, as will its motion control, power supply, thermal control, and tracking systems. 9 minutes after launch, at an altitude of 115 statute miles, the rocket's third stage will complete its burn, and Zaria will separate from the Proton to begin its life on orbit. 1 minute later, with the motion control system deactivated, an automatic sequence on board Zaria will activate antennas for the rendezvous and docking system, known as the KURS, and for the Comparis system, which receives and processes automatic commands sent from Russian ground stations. The sequence will also begin the deployment of the solar arrays, which will start to follow the sun's movement to supply Zaria with electrical power. An hour and a half into the flight, another automatic command will tell the major systems on board Zaria to transition from standby to active status, including the motion control system. Its first activity will be to place Zaria in a stable orientation. Later, it will initiate a slow spin of Zaria along two of its axes as a means of conserving propellant and maintaining even heating and cooling. Tomorrow, Russian ground controllers will monitor a firing of one of the module's two main engines to test its performance. About 2 hours later, the same engine will be fired again for 100 seconds to raise the perigee, or low end, of the module's elliptical orbit to an altitude of 153 statute miles. Then, after a day of monitoring onboard systems to ensure their proper operation, Russian controllers will again maneuver Zaria to the proper orientation to adjust its orbit once again. A main engine will be fired to circularize Zaria's orbit at an altitude of 242 statute miles, where it will await a rendezvous with the shuttle Endeavour in just over 2 weeks. Next week, ground controllers will test Zaria's onboard computers and the TORU, or Teleoperator Control System, a backup docking system that allows the robotic operation of the control module. Then, the following day, Zaria will be maneuvered once again to confirm its ability to support its capture by Endeavour's astronauts, to confirm the effect of that orientation on the charging of its batteries, and to assess the performance of its solar arrays. With that complete, Zaria will resume its slow two-axis roll while Russian and American flight controllers monitor systems to confirm the module's readiness for its rendezvous, grapple, and mating to the Unity connecting node during the inaugural shuttle assembly mission for the International Space Station, targeted for a December 3rd launch.
Well, that report there from NASA television. Well, as we've said earlier, the International Space Station has a modular construction, and today only the Zaria module will actually be launched from Baikonur. But this doesn't mean that the launch is not significant. What's crucially important is that Zaria gets into the correct orbit. This is because all the subsequent modules have to arrive at the same point in space for assembly to proceed. Now, changing the orbit would use vital fuel and could affect later missions. Fortunately, the Proton launcher is very reliable and it's been used over 240 times.
The Baikonur Cosmodrome in Kazakhstan has a famous past. It was used for the launch of Sputnik 1 in 1957 and the first man in space, Yuri Gagarin, in 1961. Since then, it has become the center for many Proton launches, the vehicle that will carry the Zaria module today. Zaria, also known as the FGB, or Functional Cargo Block, is the first module of the International Space Station to be sent into space. It was built at the Kunichev State Research and Production Space Center in Moscow. It weighs about 20 tons and is over 12.5 meters long by 4 meters in diameter. It's a pressurized module and is designed to be the core of the early space station assembly. From it, astronauts will be able to activate all the essential operational systems. The Zaria carries all the propulsion and attitude control for maintaining the orbit and will provide all the electrical power and communications equipment for later missions. During the initial stages of the space station's construction, the Zaria will define the altitude and inclination of the orbit. It's important to control this because subsequent space station modules need to be launched into similar orbits. 13 days after today's launch of Zaria, a second module, the American-built Node 1, called Unity, will be carried into space by the space shuttle Endeavour. This mission, STS-88, is scheduled for the 3rd of December. Unity is the first of 3 pressurized nodes which act as connection points between modules. Nodes 2 and 3 will be designed and built in Europe. Once in orbit, Endeavour will bring the node to an upright position in its cargo bay and capture the Zaria module. The shuttle's robotic arm will then guide the two elements together. Following this, A series of spacewalks will enable astronauts to make all the necessary connections so the modules can become operational. Therefore, for the International Space Station Assembly Program to progress smoothly, today's launch is critically important and will become a significant milestone in space history.
Now, Thomas, you've been to a few rocket launches in your time, haven't you? How many?
Well, actually, there were 3 launches, and one of them was my own.
And which one was the most nerve-wracking?
Well, if you are sitting in this Soyuz rocket and waiting for the ignition of the main engine, this is quite nerve-wracking, yes.
I imagine. How do you feel today from the sort of this side of the desk? You know, you're not actually taking part as such. How do you feel?
Well, of course, you would like to be on the top of this rocket. Of course, the Proton is not a carrier, a booster, which is built for manned spaceflight. But still, you know, this is the start of a new era for manned spaceflight, and therefore you are tending to, you know, when will it start? When will the next chance to go to orbit be?
So you still feel very excited about the whole thing?
Definitely.
Okay, I think we've got some rollout pictures coming up of actually where the rocket was yesterday. Perhaps you could talk us through this, Thomas.
Yes, you can see the rollout of the Proton launcher, which usually takes place in the dawn, early in the morning, or late in the evening. You see the Proton lying on a railroad wagon. And this is one of the big differences to the way how those rockets are delivered to the launch pad in the United States. The Proton is assembled in horizontal way and then put on this railroad wagon and brought to the launch pad, where it is erected and then ready for refueling. It's a very beautiful view usually. When the rocket rolls out in the early morning, you see the sunrise, as it has been for our launch of the Oromir 95 mission. The launcher, you can see, has a length of 57 meters. It's quite a huge booster.
It's a very different process, isn't it, in America to the Russian system. What do you know of the Russian system of launching rockets?
Well, as I already mentioned, they are integrating the payloads in a special house, and then the whole parts are integrated or assembled in a horizontal way, put on this railroad wagon and then transferred to the launch pad.
Okay. Thomas, thank you very much indeed for the moment. Well, we're actually joined now by Professor Utkin, the director of SNIMISH, who are responsible for most of the Russian space program and also the sub-control center in Moscow. Now, earlier, I asked him how does he see the International Space Station and his country's role in it.
Role of Russia, due to the great experience which we have gained during operations with manned space stations for the period of more than 30 years, I see it of a major scale. Because in these years we are handing over this experience into the development of the International Space Station. We are going together with the Mission Control Center in Houston and in Moscow, control the station and its assembly and deployment. It's a major important role, and we are looking forward together with all the station development to meet it on a high level.
It is extremely exciting, and as you say, you have a lot of experience. How do you see the International Space Station actually benefiting from your experience?
Это действительно очень серьезно и очень это глобально имеет значение на международной арене. Как вы видите конкретно роль вашего опыта на мире в развертывании Международной космической станции?
Как я уже сказал, более 30
лет мы занимаемся пилотируем программой. Естественно, за эти годы мы накопили исключительно большущий опыт. И здесь мы видим несколько этапов. Первый этап – это передача опыта и обучение, работы на длительные, работы астронавтов на этой станции. And secondly, the second stage, the most important one, essentially Mir station now at the moment is the International Station, where astronauts and cosmonauts are working together. Thus, this is in a way invisible development stage of the International Space Station. Astronauts spent 975 days altogether in Mir station. They have conducted enormous amount of research. I want also to draw your attention to the fact that Mir station was designed for much shorter lifetime. We have learned to extend the lifetimes, the resource of the station. This is a great investment into the International Space Station, which has to fly for 15 years. It is hard to overestimate the role of the International Space Station as a stage in the development of such a major international undertaking on which we are working together. And the most important result is that mistrust which used to be in the society, we today dissipated it completely. We are absolutely confident in our outlook into the future. We are sure that we will develop outstanding International Space Station. This is the building of the 21st century.
Indeed, the sky is the limit. We're about to see the launch of Zaria, the first element. Could you briefly describe its role?
Мы на пороге пуска элемента Заря. Опишите, пожалуйста, коротко его роль.
Ну, естественно, это первое начало движения в развитии международной космической станции. Отсюда, с этого узла, начнется завязываться международный космическая станция. Поэтому на очень большие функции и задачи возложены на этот первый международный, который полетит. Здесь будет обеспечено следующий стык с узлом американским Node 1. И дальше придет время, когда туда подстыковывается служебный модуль. На этот модуль
On this Zaria module, which is due to fly, we are assigning the tasks of providing power supply, certain issues of life support systems. There we built in lots of power consumption matters. We built in the control systems and maintenance of trajectory, stabilization, provisions for docking. Basically, it's the beginning of life of the station. And of course, we are all, with great attention, are treating this work. It is enormously responsible, and it gives, as I've already mentioned, it gives birth to the beginning of the long way of the development of the International Space Station.
Well, we'll hear more from Professor Utkin again after the launch. Well, we can now go over to Mission Control in Moscow, where we have our reporter, Christian Feichtinger. Christian, good morning to you.
Good morning.
Hello.
Good morning to Estek.
What's happening over there?
Well, a few minutes ago we got the announcement of the 10 minutes readiness to launch here in Zub. And now we are about 5 minutes before launch of Zaria, the first module of the International Space Station. The internal power supply of the Zaria module has already been switched now to battery, internal battery, and the proton launcher is ready to be launched in 4 minutes.
Okay, Christian, 4 minutes to go. What's the atmosphere like?
Well, it's quite hectic here. It's a lot of press interest here. And on the other hand, we see that the ground controllers seem to be very cool and very calm and ready for the big task.
Thomas wishes he was there. I think he'd like to ask you a couple of things, Christian.
Definitely. Christian, how did the preparations of the launch go? Was everything nominal?
Everything was nominal, yes. The actual immediate preparation for launch started about 8 hours before the planned launch time, today in the night at about 11:40 your time, with an activation of the booster. And then the most hazardous operation, the loading of the booster rocket with fuel and with oxidizer, started in the night. This was a procedure of about 4 hours, and that went well, okay. And afterwards, all the systems were activated again, checked again, and the readiness of every single system was received. And we are ready now to launch in a few minutes.
Is everybody very confident there?
Oh yes, everybody is very confident and aware of the big moment which is in front of us.
Listen, I guess you also have been to a Proton launch before, live in Baikonur, and we both remember how impressive this is. I think you also wish to be there and take part on the launch pad, in fact.
Yes, you're right. Of course, it's already very impressive to see it on screen, but it is a lot more impressive even if you see it really live. And the very light which you see, the sound which you hear, the vibration which you feel, of course you can't get that via the video pictures.
It's a shame that we can't be with you, Christian. We're very excited. Now, we've only got 3 minutes to go to the launch now. Shall we go on to the pictures so that we can all, fingers crossed, and hope it happens? Christian, can you still hear me?
Yes, now I can hear you again.
Oh, excellent. What actually has happened in the build-up to the launch in terms of activity?
As I already said, the main activity today during the night was the loading of the booster with oxidizer and with fuel. Afterwards, all the systems were checked again and activated. And now, in the last hour before the launch, the final readiness of all systems was received. Especially important in this period is the final adjustment of the trajectory control system, of the gyro-controlled platform of this system, which was also done successfully. And now actually everybody is just waiting for the command, which will be given about 2.5 seconds before liftoff. The command for the main engines will be given, and 1.6 seconds before liftoff, the main engines will be ignited.
Maybe this is a good moment to talk about some technical details of the launcher, which we see here in the picture. It's 57 meters high, and this rocket you see standing there has a total mass of approximately 690 tons, of which the major part is fuel, 622 tons of fuel, which will bring the module up into space. At the moment of launch, the first stage will develop a thrust of 950 tons and lift up the Zaria module with approximately the acceleration of 1.5 Gs.
Let's just sit back now and watch the launch. A minute to go.
Go. 6 in.
Space construction will require 45 space missions. 60 spacewalks. Direction of space are said to be high. Dana Lewis, NBC News, Moscow. Safety factor risky. The darkness of space construction require 45 space an incredible 160 spacewalks. Odds for major accident in space are said to be high. Dana Lewis, NBC News, Moscow.
On my left side is Professor Utkin from Russia. Professor Utkin, я поздравляю вас с успешным стартом. Now the launch has been successfully conducted. What are your feelings?
Профессор Уткин, пуск прошел успешно. Какие у вас чувства по этому поводу?
Ну, естественно, чувство очень серьезно довольно той работой, которую провели. Дело в том, что идет полет, сейчас будет отделение первой ступени, обтекатели и так далее. То есть этот процесс будет идти в течение 10 минут. Будем надеяться, что он будет проходить в том режиме, в том понимании, которое...
Of course, it's a sense of great satisfaction, and now we are about to witness separation of the first stage and jettison fairing. So we are hoping that for the next 10 minutes everything will go according to the schedule and we will have final entry into orbit.
Начало большого пути.
This is the landmark, the beginning of a big way to go.
In the meantime, the first stage has separated and we are now waiting for the news from the control center that the orbit injection has gone also successfully, which I think is no doubt at all, because the proton launcher is known as being a very reliable booster.
За это время уже отделилась первая ступень, и мы теперь ждем новостей из ЦУПа, что дальнейший процесс идет успешно. Мы знаем, что протон очень успешный носитель.
Он надежный носитель. Будем мы надеяться, что он справится с сегодняшней задачей и даст возможность нам это увидеть.
Indeed, Proton is a very reliable launcher, and we hope and we are confident that it will let us resolve this important task, and we're about to witness it in a few minutes.
Thank you, Professor Utkin.
Well, success so far. Mr. Feustel, a great day for Europe, but of course, what comes next?
But first of all, I have to say that this is, of course, a fantastic moment. After 10 years of preparation, now we are in the most important 10 minutes. So that's really an exciting moment, and I would like to congratulate our Russian friends for their, hopefully, success. We have still to wait a few minutes, but also the space station community altogether, which has contributed to that success. It is now the first stepping stone, and we will take the relay all together in order to build up the station in the next years. But it will now go very fast. In already 3 weeks from now, on the 3rd of December, there will be Unity launched, that is an American element. And then next year, we will have 5 more launches with elements and resupply. And end of next year, you will already see the first crew of 3 on board of the International Space Station. So it all goes now with a big thrust, and we are going to build up the station.
Excellent. Mr. Kroll, I'd like to ask you now, obviously you're very pleased. How important is today's launch for the future of the station?
Let me first say that although the launch into space has meanwhile become more or less an everyday's event, there is always release and satisfaction after a successful launch, because these high-tech enterprises, although professionally prepared with big routine, are never 100% guaranteed success. So again, congratulations and felicitation to our Russian friends and to all who have been involved. With this special launch bringing up the first element for the International Space Station, I think all of us involved feel a little bit like those who lay the foundation stone of a house. after a long period of discussion, of controversial arguments, pro and cons, of planning, one is released and happy when the foundation stone is laid. So things become real now. At the same time, one, of course, is hoping that everything goes as planned, in time, in costs, and that things finally turn out to please everybody, to convince those who still are skeptic or critical, and to encourage our youth especially to be motivated to do research and devote some of their enthusiasm and their creativity to make space integrated in our life. After the first step, like in building a house, everybody is curious to see the next step, and there are many steps to go.
Exactly. Well, I think perhaps we ought to go back to Moscow.
Yes, let's hear from Moscow, from the control center, how things are going there. Christian, how is the launch proceeding?
Well, everything is proceeding very well. The second stage has been successfully separated, and now the third stage is working, and we get the constant confirmation that it's working well according to norm.
But at what cost?
So orbit injection is imminent, I suppose. It's almost 10 minutes now.
It will take us another 2 to 3 minutes to be at the point of orbit injection, which will bring the Zaria module in an elliptic orbit around the Earth at an altitude of about 180 to 340 kilometers.
Is there a chance to follow the trajectory over there in Zug?
Yes, we can follow the trajectory here in a graphic display on the main screen of the control center.
Yeah, I can see it over your left shoulder. Huh? Yeah, excellent.
So we can see there the height of the altitude of the booster rocket, as well as the overloads.
See, the maximum is around 4.5 Gs, which is quite a lot. If you would be sitting inside the Zaria module, you definitely could feel that acceleration, find it hard to breathe and to talk probably.
Oh yes, for sure.
Christian, thank you very much indeed. Thank you. So the Zaria module is safely launched, and in a sense, the real work begins. For Europe, the first piece of hardware into space is a computer management system known as DMS-R. This will be used to control the Russian service module, launched in just a few months' time. In the initial phases of the assembly, this system will be used to control the entire space station. Europe is also building a permanent module for the station, the Columbus module, which I was standing in front of at the very beginning of this program. Now, the Columbus laboratory is about 7 meters long by 4.5 meters in diameter, and it will provide high-quality research facilities for at least 10 years.
In many ways, the Columbus Laboratory is an improved version of Europe's Space Lab. Research in orbit was pioneered on Spacelab, but flights were limited to only several days at a time. The Columbus Laboratory will have a big advantage, namely the capability of long-term space research, which is repeatable many times over. Its equipment is housed in movable and exchangeable racks, which run the length of the module. These are designed to hold experimental facilities, some with automated procedures, others needing the attention of astronauts or scientists on the ground via telescience. Fields of study include fluid physics, life sciences, fundamental physics, and technology. The aim is to offer great flexibility. A rapid reconfiguration of the Columbus Laboratory is possible for new modes of operation by fitting replacement racks from Earth. An orbiting laboratory is needed when studying biological, physical, and technical processes which are affected by gravity. On Earth, gravity is everywhere. It holds us to the planet's surface. It's been present throughout millions of years of biological evolution. So to investigate biological processes at a fundamental level and to understand the role of gravity, it's necessary to go into space. Gravity can also mask the workings of other physical forces during simple processes on Earth. So to understand what's happening during melting or solidification, crystallization or convection, experiments need to be done in weightless conditions to avoid gravity affecting the results. Of course, in orbit above the Earth, gravity is present. Otherwise, satellites such as the space shuttle would just float away. But by virtue of the speed with which the shuttle flies around the Earth, the effect is to counterbalance gravity and create conditions of weightlessness on board. Research on Spacelab has already generated new results, and work in the Columbus laboratory will further these. One important area of research is the investigation of the human vestibular system. These sense organs, situated in the inner ear, detect movement and body orientation and are essential for balance. How they work can be studied indirectly through eye movements, which are partly controlled through this part of the nervous system. Experiments on the ground and in space can help us understand how the brain uses this information. The information can help us understand complex neurological complaints such as Parkinson's disease. Other studies in weightlessness are directed at examining the effect of gravity on bone structure. These could lead to new insights into osteoporosis, a common complaint that doctors have to treat on Earth. In the future, teams of 3 astronauts will be able to spend up to 3 months at a time working on Columbus. And given the long duration of missions, it's hoped new experiments, not possible at present, will be developed.
Well, ladies and gentlemen, just we got the message from Moscow that orbit injection of the Zaria module was successful. Now everything is on track as planned. With me I have now Dr. Raimondo Fortessa, who is the Center Director of MARS, which is an abbreviation for the Microgravity Advanced Research and Support Center. Mr. Fortessa, the station is sometimes called the most advanced research institute in space. What are the new capabilities of the station as compared to former programs?
First of all, it's a very huge infrastructure. You have to consider that the volume available is equivalent to a ground lab of 450 square meters. So it's very big infrastructure, and you can perform a lot of experiments on board. The diagnostics on board and the lab installed are the most advanced one. And the capability to be permanently manned and serviced every 3 months gives the user the possibility to perform continuously experiment. In the past, the user were used to perform experiment every 4 years. That is a little bit too long to have a continuity in the research. Now, with this new infrastructure, we will continue to perform experiment year by year, thanks to the infrastructure available. And in addition to that, ESA is not building only the space infrastructure, but also new ground infrastructure, providing the capability to the user to control their own experiment for their lab directly using this telescience approach. That's quite important for them.
I think these facts are especially showing that this has some kind of advantage over unmanned kind of experimenting. In which disciplines will there be experiments conducted in the Columbus laboratory?
Well, there are several labs in the Columbus dedicated to discipline like material science, so we can grow up crystals and we can obtain new alloys and new materials. We have a fluid science lab when we can perform experiment on fluids, experiment on combustion, experiment in protein crystallization. We have a dedicated facility for protein crystallization. We have a biolab using which you can compare experiment performed on cell and small plants with the 1G reference test, so simultaneously Actually, they are made with the 1G and the 0G to compare the results. And we have a material science, it will be installed also in US labs, so the material science laboratory will be available early in advance respect to the one installed, the other lab installed in the Columbus. And we have additional facility like human physiology module to perform experiment on life science. So the broad range of experiment can be performed on board. So without considering the external platform where we can perform experiment also in the exobiology, astrophysics, solar physics, Earth observation, and so on. So we have a broad spectrum. Exactly.
Thank you, Dr. Fortezza. Also with us, we have now Dr. André Küpers, who is a medical doctor and life science expert for ESA. André, now you are going to join the European Astronaut Corps. Welcome in the club. And you are going to fly on the station. Congratulations. How do you feel?
Well, it's a big honor and a pleasure, of course, to work in the future in the station, which we see the first build-up now, to work with the payloads that I've been helping to prepare. That's a very pleasant idea.
Well, now you have been a developer, but as an astronaut you will have tasks to perform yourself, of course, and your colleagues on the stations. Can you reflect a little bit? Which kind of tasks will there be?
Yeah, the ESA astronauts will have the same tasks as all the other astronauts from the other countries on board. And there are several tasks. One of the big tasks, of course, the task of board engineer, to take care, to maintain the station and take care of the environmental system. And it could be tasks inside of the station, but also outside. One of the tasks will also be to operate the robot arms. Another big task of the astronauts will, of course, be the performance of experiments, as has been explained just now. Many experiments in different fields. And in my own field of the life sciences, it's very important, of course, that the astronauts are there because we need them as test subjects.
Yes. Can you give us some examples from your own experience? Which kind of medical experiments were you involved in?
Yeah, the experiments that have been performed in the past and will certainly be performed on the space station are, for example, experiments on bone loss, what we see in astronauts, muscle atrophy. Astronauts don't use their muscle so much and they lose the performance in that. But also fundamental research in lung physiology. The vestibular organ is an important part, and all those research areas will be attended in the future of the space station.
And apart from doing maintenance on the station, I guess it's also a big task to do maintenance on all these experimental hardware which you are working with.
Absolutely. Of course, many tasks are automated, but especially in case of unforeseen problems, it's very important that there are humans on board who can solve these problems.
Okay. Thank you to Dr. André Küpers.
Well, what a fantastic experience that's going to be. Lucky, lucky man. Well, for the very last time, let's go back to mission control in Moscow. Now, Christian, we've heard that we have achieved orbit injection. Any more news that you can give us?
Yes, we have the confirmation that the FGB, the Zaria module, has been successfully inserted in an elliptic orbit with the orbital parameters of 185 kilometers altitude in the perigee and 385 kilometers in the apogee. And Zaria is now orbiting around the Earth with an orbital period of 86 minutes. This orbit will not be the final docking orbit. The final docking orbit will be a cylindric orbit in a height of 385 kilometers, and this one will be reached within the next 5 days after a series of 5 more impulse maneuvers.
Well, Christian, it's been absolutely wonderful talking to you. Thank you so much for bringing us all the information. We're going to say goodbye to you now, but thank you very much indeed. Thomas.
Welcome. Goodbye to ESTEC.
Thank you.
Just to give you an idea how complex an undertaking the assembly of the International Space Station is, we have constructed a little video sequence that shows you all the stages of the construction.
fascinating sequence, and of course it doesn't all happen that quickly, does it? Professor Kroll, I'd like to come to you. Now, Germany is home to the main contractor for the Columbus laboratory. Is everything on time?
Everything is on time. We, as has been said before, have already delivered something, the data management system, which is more or less the brain of the Russian service module. The manufacturing of the Columbus and all other European contributions are on time. I'm sure that European nations joining their forces will demonstrate in this global endeavor that they are competent and reliable partners who deliver on time, high-quality contributions to their international allies.
Will Europe be there for the rendezvous?
They will.
A very confident man. Mr. Feustel, now that the station's build-up has started, how do you prepare for its utilization?
When we started the program in '95, we did not only start the build-up of our hardware in orbit and for the logistics, but we started at the same time to prepare for utilization. And we will already have our first experiments on board of the station mid of next year, where we start together with our Russian friends some experiments, quite interesting ones. And we are actually triggering activities in research, in technology, and also in applications since the very beginning of our effort. And we just had a big symposium here in ESTEC. And at the same time, and this is a particular pleasure for me to announce it here, we invited through an announcement of opportunity, we call it, but that's an invitation for all researchers and industrialists in Europe to provide proposals for experiments on board of the International Space Station, namely in the Columbus module. So we are already now making very concrete steps. And we have not only invited researchers and technologists, but we have also invited European students. And we started together with a small company an undertaking which is called Success, where we invite 1 million European students all over Europe to come forward with ideas and proposals what we can do on board of the space station. So we try to get hold of the whole community to make the best use of it.
Have you had any feedback from that yet, or is it far too early to say?
That's a bit early because it is just initiated a few days ago, but from the scientific world, we had a lot of feedbacks in the past years, and there is quite a number of experiments in research and also in technology which will be carried out and further developed in the coming years.
Can I just ask you, obviously everything has gone very successfully today. Personally, how do you feel? Because obviously you must have overcome an awful lot of challenges over the last 5 years. Professor Kroll, how do you feel, you know, emotionally?
As I said earlier, released with hope, with confidence, and what we all need in the ongoing endeavor which just started is something which you never can guarantee. Good luck.
Yes. Mr. Feustel, very briefly, how do you feel?
But I feel splendid, I must say, because all the feelings of 10 years of work are condensed in 10 minutes, and you can imagine that is a moment of high density and tension, and of course also of high emotion if everything goes well. So I'm excited and very pleased that we have now the first step done.
Excellent, thank you. Thomas?
Well, as Mr. Feustel has just mentioned, the announcement of opportunities for the scientific experiments. Let me ask now Dr. Fortessa, what are the main disciplines which have been in the announcement of opportunities?
This announcement of opportunities is dedicated to physics, science and biotechnologies. The deadline is end of February, mid of February, so and it is possible to access to through World Wide Web to see this information, so they are available to all the European partners. And of course, physical science means any experiment in material science, so crystals, alloys, and possibility to have new structured materials And we have fluid physics, means utilization of this fluid science lab, so information about surface tension. We have the possibility to perform experiments without hydrostatic pressure. They are very important for understanding of the phenomena, the basic phenomena. And then we can perform experiments on combustion. That also is very important to improve the efficiency of the engine on Earth, so on droplets and on spray, on clouds.
So we have quite a wide spectrum of also opportunities from the user community. Let me now finally come to Mr. Guinet. The station is not only meant to be used by scientists, but also as a platform for technological experiments. Is industry interested in utilizing the station?
The industry is quite interested in utilizing the station, obviously, because it's an ideal test bench. It's an in-orbit test bench where you can see behavior of your product, which you cannot see on ground. It allows industry to understand new concepts and to improve industrial processes. And there were in the past experiments implemented in orbit for industry, like light, large structure, prefiguring the antennas for large satellite, telecommunication satellite. And this is quite an achievement for industry. We are preparing ourselves a proposal for an in-orbit test of a fluid loop. A fluid loop is a device which is mounted on a telecommunication spacecraft to distribute heat over the spacecraft, and you cannot test that really on ground. You need to go somewhere in orbit.
Yeah, so
this is
So I see there is already a lot of work in hand towards utilization of the station. One important tool in trying to understand the logistics of setting up a research experiment is virtual reality. And so to get an idea of what this can do, we are going to show you a brief glimpse of how this works.
Starting on the left here, we have the European Columbus Orbital Facility, which is an experiment laboratory. There are also some experiments mounted on external pallets here. And what you see here moving is the European Robot Arm, or ERA. Shown approaching from the rear is the ATV, or Automated Transfer Vehicle. This is built by Europe and will be launched on Ariane 5. So I'm now approaching it from below. We're going to have a look inside. So we're now inside the airlock. So this is now the inside of the Columbus Orbital Facility. This is an experiment laboratory for experiments in microgravity. So I'm now turning around and we're going to retrace our steps back to Node 1. I've opened the door now, and now we're going to flow back out into space.
Mr. Feusler, at the beginning of the program, Kate said that this building was being converted into an ISS user center. What exactly is going to happen here, and how will it be used?
We are presently building up an International Space Station Utilization Information Center here in this building. And this will allow all new users which are interested in utilizing the space station to get familiarized with the space station. So we will display models like the Columbus will be in scale 1 and everybody can see it and walk through it. We will display experiment examples so that the potential users see what you can do on board of the space station. And we will have a huge library here, which will supply all information about experiments, backgrounds, and results. So we try to establish a focal point for all potential users that can get all relevant information in order to prepare themselves for hopefully a good utilization of the space station.
So can all the user community also, let's say, try here to integrate all their systems and see that their hardware is properly functioning in this hardware on board the Columbus?
The test of the experiments is normally done at the site where the facilities are developed, so that will not be done here, but in form of models, they will be able to study also the integration of their experiments, but the real hardware will be developed at the industrial sites or at the integration sites.
Checked out. So this is mainly used to demonstrate how work is being conducted on board Columbus, how it basically looks like in this area.
Exactly. And we will provide through that all informations which a user needs in order to understand this complicated machine. But at the same time, we will also use it, as we have done today, as a communication center, as a communication node, so that we can inform Europe on the forthcoming 49 further flights which are coming up for the space station assembly.
Professor Kröll, the user center, of course, will also be for you a very important asset to demonstrate how people how scientists are working with this scientific hardware.
There will be a decentralized system of user centers in Italy, Mars, in France, Katmos, and as well in Germany, Köln-Porz, DLR, where we have a microgravity user support center, yes, to help users integrate and operate their experiments in space from a familiarized environment at home.
Yes. So thank you very much. We are now, I hope, in line again with Moscow and just can get a last update. Okay, so we are not in line. I think everything is going well now. So that always concludes today's program. I'd like to thank all our studio guests and to say goodbye to our German visitors on Bavarian Alpha. And please, over to Kate.
Thank you very much, Thomas. Well, from Hestech here in the Netherlands, in the Space Station User Information Centre, it is goodbye, but only for today. On December the 3rd, the second unit, Node 1, or Unity, will blast off from Kennedy Space Centre aboard the shuttle Endeavour. On that occasion, ESA will be broadcasting from the German Space Centre in Cologne in conjunction with DLR. And there will, of course, be many more occasions over the next few years. But for now, from all of us here, goodbye.
Main engine start, 6 engines up and running. And liftoff. Liftoff of the Proton rocket and the Zaria control module. The International Space Station is underway. The Proton building up thrust, good roll and pitch program according to flight controllers. The first component of the International Space Station heading toward orbit. Seconds into the flight. Good first stage performance. Proton delivering 1.9 million pounds of thrust from its 6 engines. And first stage measures 68 feet in length, 24 feet in diameter as it burns for the first 2 minutes and 6 seconds of the flight. Proton now fading from view into the overcast skies.
Okay, we're trying to...